Some electric cars include a heat pump as standard. On other models, it is an expensive option. But does a heat pump really increase range? Or is it equipment you do not need? The answer depends on where you live, how you drive, and how often you need the maximum possible winter range. In this video, we explain how a heat pump works, when it makes the biggest difference, and who can comfortably manage without one. First, we need to understand why heating matters so much in an electric car. A petrol or diesel engine produces a large amount of waste heat. Some of that heat can be used to warm the cabin. An electric motor is much more efficient and creates far less waste heat. The EV must therefore use energy from the battery to keep the cabin warm. The simplest solution is an electric resistance heater. It works like a powerful space heater. Electrical energy is converted directly into heat. A heat pump works differently. It moves heat from the outside air or from other parts of the vehicle into the cabin. Under suitable conditions, it can deliver more heat per kilowatt hour than a resistance heater. A technical review from the United States Department of Energy found that automotive heat pumps can be 3 to 4 times as efficient as resistance heating under certain cold test conditions. That does not mean every heat pump EV automatically travels 3 or 4 times farther. Cabin heating is only one part of total energy use. Speed, tires, wind, temperature, battery condition, and driving style still matter. It also does not mean that a heat pump is equally effective at every temperature. In extreme cold, there is less heat available in the outside air. In extreme cold, there is less heat available in the outside air. The system may need support from an electric resistance heater. Many cars combine both systems to provide fast and reliable heating. How much range can a heat pump save? There is no single number that applies to every model. The result depends on system design, temperature, journey length, and the cabin temperature you choose. On a long winter drive, an efficient heat pump can save a noticeable amount of energy. On a short trip, the car uses a lot of energy to warm a cold cabin at the beginning. The heat pump may still help, but there may not be enough time for the total saving to become large. If the car is plugged in at home, you can preheat it before departure. More of the initial heating energy then comes from the electricity grid instead of the traction battery. This can reduce some of the disadvantage of an EV without a heat pump. Heated seats and a heated steering wheel can also provide comfort while using less energy than heating the entire cabin to a very high temperature. Heated seats and a heated steering wheel can also provide comfort while using less energy than heating the entire cabin to a very high temperature. But you always need enough heat for clear windows and safe driving. Never save energy by driving with ice or condensation blocking your view. Who should prioritize a heat pump? If you live in Norway or another cold climate, drive frequently in winter, and often use a large share of the car's range, a heat pump is usually a sensible choice. It is especially helpful if you drive long distances in cold conditions, cannot always charge at home. It is especially helpful if you drive long distances in cold conditions, cannot always charge at home, or want a larger safety margin between charging stops. A heat pump may also help resale value in cold markets, because many used EV buyers actively look for this feature. Who can manage without one? If the car is mainly used for short urban trips, is parked in a garage, can be preheated while plugged in, and has far more range than you normally need, a heat pump is less important. And has far more range than you normally need, a heat pump is less important. The same may be true when the option is very expensive and the car otherwise fits your needs extremely well. An EV without a heat pump is not a bad EV. It can still provide effective heating and work well through winter. The difference is that it may use more battery energy to create the same cabin temperature. The difference is that it may use more battery energy to create the same cabin temperature. It is also important not to judge a car only by the words heat pump. 2 cars with heat pumps can have very different winter consumption. Aerodynamics, weight, battery conditioning, tires, motors, and software all affect the result. Look for independent winter tests of the exact model you are considering. Compare real energy consumption, winter range, and how quickly the cabin becomes warm. If you are buying used, check that the heat pump actually works. Unusual sounds, weak heating, or warning messages may need investigation. The climate control and heat pump systems often share components. And repairs outside warranty can be expensive. Here is a simple way to decide. Ask how often you drive long distances below freezing. Find out how much extra the heat pump costs on that model. Compare winter tests with and without the heat pump if those tests are available. Consider whether you can preheat the car while it remains connected to power. And remember that a larger battery is not always a better investment than a more efficient vehicle. The conclusion is that an EV does not need a heat pump simply to work in winter. But for many drivers in cold climates, it is useful. It can reduce heating energy, improve the winter range margin, and make long journeys easier. If you only drive short trips and can always charge at home, you may manage perfectly well without one. If winter range is important, I would choose the heat pump when the price difference is reasonable. Does your electric car have a heat pump, and do you notice the difference in winter consumption? Tell us in the comments.